On the first page of your review, we're going to take a look at numbers 4 and 6. Number 4 is a division problem. Division and multiplication of fractions we treat very similarly. The difference is that with division, we have to remember that when we divide fractions, we keep that first term the same, but we multiply by the reciprocal of the second. So I'm going to right away rewrite this, keeping that first term the same. 7x plus 6, and then multiply by the reciprocal of that second term. So I'll be flipping this second term. So 3x minus 3 over 2x. At this point now, I want to factor any terms in here that I can factor so that I can reduce before I finish my multiplying. So if I look at my first term here, my first numerator, I have a GCF of 2x that I can factor out. That would leave me with x minus 6. That first denominator is a trinomial. Factors of 6 that add to negative 7 would be negative 1 and negative 6, so x minus 6 times x minus 1. And then my second numerator here has a GCF of 3, so I can pull out that 3, and I'm left with x minus 1. And then my last term, 2x, is simply just 2 times x. So now I can reduce any factors that are common between the top and the bottom. So I have a factor of 2 and a factor of 2. Remember, when I reduce, I'm reducing down to 1. Same thing with my x here and my x here, reduce down to 1. If you wanted to take the whole 2x with the whole 2x, that would also be fine. I'm just illustrating that we can also reduce those individual parts since I'm multiplying. Here I can take x minus 6 and reduce with x minus 6. Notice that I cannot reduce x with x, and I could not have reduced x squared with x squared because these are this x squared here and this one here are part of larger terms. Same as my x and x. So I can take the whole piece and reduce that down to 1. But I cannot take individual bits and pieces out of my expressions here. And then the last thing I can reduce is this factor of x minus 1. And when we're reducing, it's one term from the top with one term from the bottom. Left over now on top, I have 1 times 1 times 1 times 1 times 3 times 1. And on bottom, just a whole bunch of 1s, giving me 3 over 1, or plain old 3. Multiplying, if my original problem was multiplying would be much the same way. I just wouldn't have to flip that second term. The other problem I want to look at on the front page is number 6. Number 6, we are adding two fractions. Remember, anytime I'm going to add or subtract fractions, I have to have a common denominator. So my first step here is going to be to factor anything I can with these denominators. My second term is x minus 8. I don't have any GCFs there. It's not a trinomial. There's no x squareds that I can factor anymore. So that's just going to stay as x minus 8. For this second term, factors of 32 that adds a negative 12 would be negative 4 and negative 8. So I can factor this into x minus 4 times x minus 8. And now to get my common denominator, I'm going to do the same thing that we did at the very start of our unit. Here I already have a common factor of x minus 8, so that needs to be part of my common denominator. Then I'll also need to have this other factor of x minus 4 as part of my common denominator. If I take a look at my first term now, I have all the parts of the common denominator, so I don't need to do anything to the second term or to this first term. But the second term only has x minus 8. I need x minus 4 to be a part of this denominator, so I'm going to multiply by x minus 4 on top and on bottom. So now I have my first term. That's the same, x squared plus x minus 3 over, I'm going to write my common denominator in that factored form, x minus 4 times x minus 8, plus, be careful of your signs, 3x times x minus 4 over x minus 4 times x minus 8. Now at this point, it's really tempting to reduce those factors of x minus 4, but if I do that, I no longer have a common denominator and we're back to square one. So what I need to do instead is distribute this 3x. So I have 3x squared minus 12x. And again, as I'm distributing, be careful of your signs. I have an addition sign here, but if this was subtraction, I would probably want to distribute through negative 3x so that all my signs would change with that subtraction. At this point now, I can combine my like terms. So I have x squared plus 3x squared. That gives me 4x squared. And then I have x minus 12x, that would be negative 11x, minus 3 over x minus 4 times x minus 8. And there's my final answer. I've combined my like terms. It's always a good idea to look to see if you can reduce anything here. For this problem, I'm not going to be able to, but my final answer would be 4x squared minus 11x minus 3 over that common denominator that we got at the start of our problem.